Hi, everybody, and welcome to SurrealDB stream number 13. This is our first stream back since launching 1.0 back in September. So lovely to be back with you all. Today, we are going to be talking about how to handle big data properly with SurrealDB. And we'll also be diving into that with Misha and Toby in a second. But just while we're assembling, do share where you're watching from. And of course, if this is your first stream as well, we're going out live on YouTube and LinkedIn. While you're popping that in the chats and things, a few reminders: do leave any comments, any questions in the chat. We'll be monitoring this throughout the course of the stream, and Misha and Toby will be answering those questions as we go through. This, as I said, is our first stream back since the launch of 1.0, and we've also just finished Hacktoberfest, which was a really big success. We had 37 amazing participants, so now our awesome Surreal repo boasts 11 brand new starter kits for Rust, Python, JS, Go, and Java. So a really big thank you to all of the PR reviewers for making Hacktoberfest 2023 such a big success with Surreal. Thank you all. As I said, today we are joined again by Misha and Toby, and we're going to be kicking off and talking about time series data, record IDs, how searching can be affected depending on the methods used, and diving into all of that. So Toby, Misha, take it away.
Yeah, awesome. Thank you, Lizzie. So welcome everyone. Great to have you here again as we start up this stream after the launch of version 1. We get a lot of questions. I think Misha knows this a lot because he's on Discord a lot more than I am nowadays. But we get a lot of questions about how to structure your data so that it can work well for the type of querying that you want to do, and that it can work at scale or embedded mode or just single node mode. And I think because of SurrealDB's flexibility, it's a hard question to answer because it really depends on the types of queries you want to issue later on or how you're going to be inserting data. So today we'll be looking at the different ways of arranging your data when you're inserting it in order that you can do better queries later on down the line. So Misha's going to be spinning up some amazing queries, I think, on live again today.
As always, yeah.
And yeah, there you go. And yeah, so I mean, I guess Misha, where do you think we should start? There's a lot of topics. As Lizzie said, we're going to be looking at aggregate views a little bit as well, and how you can optimize pre-known aggregate queries. If you know for a dashboard you're going to be using a particular query that always groups sales by month, for instance, then using aggregate views is a great feature. We're also going to be looking at IDs and the different IDs that you can use in SurrealDB and how that affects your querying, both on insert and also later down the line. And then we'll be extending upon that with complex record IDs and what you can do with those before looking at the kind of topic of denormalization of data or normalization of data and duplication of data. So a lot of things to cover. Misha, where do you think we should start? What interests you most?
I'd say let's start ahead with the aggregate views. That's something that I've been wanting to dive into more myself as well. So perhaps we can learn something new this stream as well.
All right, brilliant. So to give a brief summary, as I did before, so aggregate views are effectively a view into your data that can be based on maybe a filter, or maybe it's a filter with a grouping, or maybe it actually selects from multiple tables and groups into a single table. So very flexible in what you can do with it. But it's one of the least known features, I think, of SurrealDB in terms of what you can get from it. So let's Misha, if you can bring up your screen, that'd be great.
Absolutely. Let's do that. There we go.
There you go.
Should be up there.
Awesome. So here we've got the brilliant Surrealist database administration UI. So effectively what you can do with aggregate views, if you know up front that you have, let's say, a whole load of temperature recordings or metrics, or maybe they're CPU metrics, and you know that you want to be, on your dashboard, you want to be displaying a certain grouping of those metrics. Maybe you want to show all the groupings for each day of the week, but also grouped by country, then an aggregate view can be used to do that. And effectively, the only cost to you as a user is an additional single write on entry. So when you're writing to the database, instead of just writing once to the record you're updating or creating, you would add an additional single write. And what you can do then on select is you can select directly from that table, and it actually is a table at the end of the day. But that table now has just a few results. So if you're grouping by day of the week, it'll only have 7, for instance. If you're grouping by country, it'll have a couple of hundred. So really, really quite clever in what you can do with it, and it's great for being able to pull that data out in advance as you need it. So here we're creating a schemaless temperatures table. My assumption is that temperatures has a date on it. We'll be adding that to the schema in a second. And then the grouped temperatures table selects from the temperature table. So this very similar to how you would define a normal table, but with this you have an as keyword at the end, and that as then has a select query after it. And that select query does have slight limitations over a traditional select query, but very flexible. So you can still do where, you can use group by. Now there's no order by, and there's a reason for that. The ordering is based on the ID of the record. But here you go. So you could say, look, I only want to select temperatures where the date is greater than now, or maybe you want to just pull out temperatures which are greater than 30 degrees Celsius. So then you'd be able to have a view which only records the temperatures which are greater than 30 degrees Celsius and which are grouped by country. So in your grouped temperatures table, there will only ever be a couple of hundred records, and those will always be updated. So in this, we've got a filter which is only looking at the temperatures greater than today minus 1 week. Now that's actually a bit of a tricky one, because if we don't update a temperature which is older than a week, then that record will never be removed from this table. And that's important to note as well. Records are removed from this table when they're updated and they no longer match a where clause. So for this, Amisha, I think if we say where temperature is greater than 25, so automatically we're looking at kind of, let's call it hot temperature recordings, and we're grouping by country. Now, the other great thing about this is you can actually do rolling averages and rolling minima and maxima as well. So instead of just select all, you might want to now say, I want to select the average temperature for each country where the temperature is greater than 25. So any temperature that's greater than 25, let's take the average of those hot temperatures and group it by the country. And then, again, when we do a select query, and we'll show that in a minute, we can actually just... it's math :
it's
average.
Math, okay. Math average.
So math average, AVG, I think. Or it might be mean. I think it might be mean.
Mean today.
Yeah. So now we're taking the average temperature for the temperature which is greater than 25 degrees, grouped by country. Now, when we want to select this on a dashboard view, for instance, later on the line, when we want to get really efficient, fast dashboard charts or dashboard metrics, or we want to maybe select from this temperature table, but we want to only select the 3 highest average temperatures. Instead of now selecting across the entire temperatures table, which could contain millions of records, we're now only effectively selecting the highest 3 from the country, average hot temperatures per country, and that will only have a couple of hundred records in it. So it's going to be an incredibly quick query, and that's great. So select all from average hot temperatures per country, order by average descending, limit 1, limit 2. So there you go. We're putting out the top 3 hottest average temperatures by country, and there you have it. So that is a predefined aggregate view which enables you to create rolling tables or filters. It enables you also to do sharding functionality as well, and often kind of unknown functionality of SerilDB as well. So if you have a users table, but you know that you're always going to be selecting the UK users or the French users or the German users, and instead of having to select from the users table where country equals France, you can actually create a table for just UK users, and then a separate table just for French users. That is always updated based on the updates or the writes to the users table itself. So then you're able to have much more optimized duplicate data. So it does increase the data storage size, but it means you've got kind of pre-filtered views of your data without any grouping that you can then use in your queries, and it makes it much more efficient if you know up front that those are the type of queries you need to be doing. So really, really interesting functionality that can be used in so many different ways. Misha, there's one thing that we haven't touched on, which is drop, but anything else that we've missed so far?
I mean, we're just at 1.0 right now, and there might be some limitations to the predefined aggregate views now, but we're still working on, expanding it and just making more sort of predefined views possible. So I'd say that's an important side note.
Yeah, definitely. And just to reiterate on the performance aspect of this, these are not views that are computed every single time you're viewing them. You can do that functionality with a custom function, with a custom select query if you want to. These are actually running up front. So they're almost like custom indexes where you can define your query up front, and it only adds, each view effectively adds an additional write for an update or a delete of a record. And that's important to note as well. When you do delete a record, if it no longer matches this view, it will be removed from this view. So any average or mean temperatures or filters or counts, these will all be updated when you delete records as well. Exactly. So there's one other feature which a lot of people don't really know what it does or why it's there, and that is the drop keyword. So now this temperatures table does a very weird thing which you'd think wouldn't really be in place in a database, and that is it drops all data. So the temperatures table, when you select all from temperature table now, it's not going to have a single temperature in there. So this is great if you have millions of writes to a table over a period of time, and you don't actually need all those writes, but what you do need are kind of aggregate charts or metrics or results over these data themselves, but not the individual data records themselves. So as Misha said, this is web scale. This enables you to create a lot of records without actually keeping or storing or using resources for those records. However, every single view that accesses the temperatures table will be updated as a temperature is written to the temperature table. So this can be really great for defining buckets or grouped aggregations or collections of data around temperatures or countries or users or anything like that, and yet without making it better for performance and without actually using more storage for data that you no longer need to keep. So let's I'm going to jump into the chat for a second. So we've got Houston. Houston, welcome. So you had select all group by before. Does that return a grouped object, or did that query apply some default aggregate? Just for brevity in the sample. So I'm not sure. So we had group by. So on an aggregate view, the group by actually creates. It gives it the table data that it stores is very similar to what a select query stores itself. So in this case, the aggregate view is actually going to be grouping those countries or grouping those temperatures together in a country. It'll only be storing the mean temperature for each country, and it'll be, in fact, actually what we probably need in this in that view, we need a country itself, so that we actually know which country the mean applies to. There you go. And we could do a count as well. So we've got country and then count and then math mean temperature. So that would give us then the country that those no, we don't need country in the count. It's just count the number of records.
Right. Yeah.
So that would give us a total number of records in that for that country, the average temperature of all the records that are put into that view, and then the country name itself. So you don't have to use groups in the aggregate views. You can just use filters, or you can just select all from multiple tables at the same time. So let's say you have 3 different tables. You've got UK users, US users, and Asian users. You could then create a user's view which selects from all of those. So there are lots of different ways that you can use these views. Alternative, the other way that Misha's doing it here is just doing a select with a filter. So being able to select from the users table where the country equals UK. And then when you want to, if you know you only need to select UK users and you're using that a lot in your application, then this is going to be much better than using a filter every time you do that. Much more optimized. So the reason we're talking about aggregate views here today is that this is a great piece of functionality, a great feature for large amounts of data and big tables, which may or may not be on a single device or running in a cluster as well. So Red Solver said, if I already have a giant table with a lot of time series data, what's the best way to set up a new aggregate view without causing downtime? We write for the main table. Yeah, so this is something we're working on. We're working on improving this. Behind the scenes, we're working on a feature that effectively creates the indexes or the views asynchronously in batches. So at the moment, if you're running on a single node, then this can be very quick. It doesn't actually have any downtime for a table because we don't lock a table. But what can happen at the moment is that view or an index, if it's a large table, can fail to be created and it might have to be retried several times. That's something we're working on, and eventually that will be using our internal change feeds functionality, so that we'll be analyzing the table for an index or an aggregate view bit by bit, and then listening to those changes so that we can catch up with the changes and apply those changes in due course. So we've definitely got some improvements along the way for that. At the moment, it doesn't lock a table like it does in some other databases, but it can. The query can fail, and retrying it would make it work. So Houston's come back. I was curious if that was shorthand for being able to apply an aggregate on it on a post as though it were indexed by the groups. So if I understand correctly, yeah. So the group by can definitely apply any aggregate that you want. You can group by multiple different fields, as long as those fields are in the field projections on line 6, 7, and 8 in the example. So you can do any aggregate you want. And in a way, this is a custom index. So yeah, it is as if it were indexed by those groups. What you can't do, I think what you're asking for is, can you actually group all of the records into the table as opposed to the aggregation of those records? It may be possible. Off the top of my head, I don't think it is, but it may be possible.
I feel like it's possible, but I can't think of it at the moment.
I'm thinking maybe something to do with array union or array distinct or something like that. And then actually, so instead of, let's say you want a record which is country UK, but you want all of those temperatures within it. I think it could be done with the array distinct function, but I'm not sure that's allowed in aggregate views. So it's definitely something we can add in if that's the thing.
I think it's possible though. I think you could select every country, and then from that array, so like an array of countries, at that point you can probably use a subquery in a select statement to gather all the countries records for that country.
There you go. Misha's going to try it out.
We need mapping functions.
One thing to bear in mind on that issue itself is you don't want each individual record to be too big, because that will affect performance, especially in a distributed context. So it's definitely possible, but if you're storing thousands of let's call them embedded rows within a row, then that's still a single record. So that's always going to have an effect. Okay, amazing. So Houston's come back on this. It's good to have this conversation as we kind of understand how other people are seeing this. So initially we had that where date is less than the date was less than 1 week ago. effectively what that was doing, it was basically saying only update this this table or the records in this table if the date is new, let's say, but it won't actually work because the date's always going to be new at the time of write, unless you're creating records retrospectively. So bit of an anti-pattern. It does work, but it's probably not what you're looking for, if that makes sense.
It's the unique function for arrays again. Just unique.
Array, yeah, or distinct. Distinct. While Misha's trying to hack away at that,
There we go.
James has asked, could you create aggregate views from graph queries too? So importantly, in order to make sure that performance works well, a graph query, I don't think you can use graph queries in the aggregate views themselves. You always have to select from the table. So you could actually select, as long as you're selecting from a table itself, whenever that table is updated, you can bring graph queries and the projections into that result as well. What you can't do is you can't traverse in the results. So you can't select from anything other than a table, if that makes sense. But anything, if you want to project outside of that, then yeah, you can definitely do that, and you can bring that data in. So it's a good way of, if you want to create kind of table caches of data, maybe with graph queries into that into those results, then yeah, you can definitely do that. Absolutely. Abukas asked the question, can I create a view for those countries where the temperature is beyond a certain threshold? Absolutely. So this is absolutely perfect for doing that. So you can create a view. Effectively, it's a custom index, and you can say, just where the temperature is greater than 25. So if you, Misha, if you jump back to query 1, I think, then you can see here on line 10, Misha's got where temperature is greater than 25. So effectively, this view is just creating grouped aggregations on any temperature that is greater than 25. And importantly to know, if you're creating let's say it's a user, you create a user and their age is less than 18, but then you update them a year later and then age is now greater than 18, then they would now re-qualify for this view if that was a part of the filter, and they would be now entered into this table. So you can definitely have filters where a value is beyond a certain threshold, and as you update the data, the view will update as well. Awesome. Misha, how are you getting on with that query of bringing results in?
It's done. There we go.
There you go. So effectively, what this is doing is it's you probably want to have the country on the record itself as well, as opposed to in each record.
Yeah.
So you'd select country and then the ID. Yeah.
I actually wanted to do as. That wouldn't work anyways. Okay, never mind.
Now this can't be done as a view though. Yeah, is that correct? Only because you're selecting from a distinct array rather than a table.
Probably,
at the moment,
yeah.
you select from a table. So we'll look into this. It's an interesting issue, but yeah, what this would enable you is you could then have a US country and all of the grouped country values inside that one record, with the only thing bearing in mind that obviously gets large. So one thing to bear in mind, Misha, as we develop out this feature, I think that brings us back to, because one of the ways that this works is through record IDs. So record IDs are the magic ingredient that make all of this functionality in SerilDB work as it does. And I think when people are coming from other databases, they don't really understand fully the power that you can get from something with record IDs, especially when you're doing, integer IDs and string IDs are one thing, and then when you move into complex IDs, they become really powerful. So let's touch on the different types of IDs that you can do in Seril. So if we just create a user or a person, so this is actually just without Toby for the minute. Cool. So if you just run that query, effectively this is going to create a person record with a random ID. Now in our case, The random ID is a cryptographically secure random ID. I can't remember how long it is, 20 characters maybe. That is very optimized for URLs. So there are no hyphens in it. There are no other odd characters. So it's perfect for URLs. Now, that doesn't work for some people. Some people need UUIDs. And I can't quite remember the exact details of it, but effectively there's a very, very small chance of these IDs ever being duplicated. However, if you are operating in a distributed context, a distributed environment, and you are writing lots of records to the database, then this is a perfect ID to use. But if you're then doing queries which select from a particular table and you want to select all people who were created at the same time, those IDs, as they're randomly created and randomly dispersed, they will be separated across the underlying storage engine. So that will always be a performance hit. So you may want to use two other types of ID. So you have the UUIDs. So we can create a person with a UUID ID. And then we can also create and there you can see the UID. Now, the annoying thing is that UID, which is, I think is V7. If you run that again, we should see it's got a similar prefix. It's not in this case. Need to, I'm not sure that. We'll look into that. But basically, that is giving you, at the moment, a version 4 unique ID. So it's going to be completely randomly dispersed. ULIDs, on the other hand, are very similar. They give you roughly the same amounts of entropy and uniqueness as a UUID. But in fact, so but they're better suited for URLs. I'm not sure why that's looking like a UUID there. But now, if you want to have more control of your IDs, you can actually give specific integers or specific strings. However, the really interesting part of the IDs in SerialDB come from complex records. And this is where you can use, for the ID part, you can use an array or an object, and you can put whatever you want in. So if we create a country first, so we know that this person is located in the UK, so we'll put UK. Yeah, and then if we generate that,
where is it? Seems like Cerealis has froze up.
If you comment out the first few examples. There you go. So this record now has an ID which has 3 parts to its actual ID. It has the current country, which we know about, so we're storing that in the ID, and then it has the current date, the date that this record was created, and then it has a random ID in case you want to ensure uniqueness over records. Now, interestingly, this is really great for time series data because we now know that all the different records that we create will be grouped next to each other on the underlying storage engine by country and then in order of date. So what we can then do is we can run some really efficient time series based queries on the person table. So if we, Misha, you're going to create some records there. If we create a few more records and a few countries as well. There you go. While you're doing that, I'll answer some questions. So Johan asked, can you set an ID to a UID by default without defining the ID on a create? So it's something we're working on. There's an issue on our GitHub to a feature request to add the definition, the ID definition on a table. And then that table will always use the same ID creation function. So yeah, definitely we're working on that at the moment, and that will be coming very soon. But right now, that ID is created on create. So Booker has asked, maybe this is to do with aggregate queries. Imagine I want to let users be able to query locations that are above a certain temperature threshold. What is the recommended way to achieve it? So you can achieve this with aggregate views with by being able to group by the location and then filter in your final query by the temperature. So definitely different ways of doing that depending on your query. Alternatively, you could create a view which always filters on the temperature threshold and then enables users to query that table and query the locations on it. So you could filter it multiple different ways, and you could use averages as well there. So Ibuka said, if there are lots of days and lots of temperature steps, Monday the 25th, Monday the 30th, view or relate, this is a great question. So it always comes down to how you're going to be querying your data. So a view is always typically how you would query things in other databases. So it's effectively a view into your data or an aggregation. You can run these at runtime, or you can predefine these up front. A relate query enables you to do some really advanced stuff with graph. So, let's say you want to model time series by graph. You could start off with a record being the current year, and then inside that year you could link down to 12 records for the months, and inside each of those months you could link down to, let's say, 30 or 31 or 28 days, 28 records for each of those months. So effectively then you could say, look, I want to find all temperature recordings between the 1st and the 30th of January 2024. So you'd go from 2024 down to January, fetch all of the links out to the days, and then fetch all of the records out from there. So it's an efficient way of doing it, but it's very different. It depends on how you want to be querying your data, how much data there is, what type of data that is as well. So definitely you can use, and this is one of the most wonderful things about Graph, you can use Graph for some great analytics purposes. Really, it's not really obvious to think about it that way, but it's definitely a way that it can be used. Awesome. So here we've created lots of records, person records, where some are in the UK, some are in the US, and some are in the Netherlands, and they're always created with the current date. Now, if we just select all from person first, Misha, if you comment out the others. Cool. So what we can see here is all the Netherlands ones are alphabetically ordered, so they come first with their dates, and all the UK ones next, and then the US will come last. Now, instead of having to create an index on this table now, what we can do in SerilDB is just effectively do a range query just between a certain country to a certain country. So if we want to find, if we comment out that query, and we now want to just find particular users in a particular country. So onto the second query. Yeah. So effectively, this is basically saying we want to find all people who begin with UK. So actually, it's not inclusive. So anything which is greater than UK or less than US, or less than or equal to US. And we can use an equal sign as well. So if we put US in there, yeah. So now this enables us to group or select without using any index from a very particular part of a table. And it enables us to do range queries up to that point. So we could then say, I want to find all people for just the US country between a certain date and a certain time. So if we just change that to US with none as a second argument, and then we go up to 2024, let's say. 2024-01-01. T.
Oh, yeah, okay. T.
00 colon 00.
Cool functions for
Z.
this.
Yeah, we need to improve that.
Z. Okay, cool. Should do it. Boom.
I guess actually, interestingly, we could probably use a function there, date time plus 1 week. That work? Time now plus 1 week. Yeah, so there you go. So now what we're doing, we're actually selecting from the beginning of all US users in that table without an index, and we're only selecting up to the end, or those users which were created up to 1 week ago. Now, obviously, that query doesn't really work because all of these users were created right now, but you might be able to then select all temperature recordings for the US between X and Y, and really efficiently without having to use filtering or queries, and without having to use indexes, you can pull out the records that you need. Now, these range queries are in our documentation, but you can use these in many different ways. So you can start from a value, and then you can end at the end of the table. So you can, if you show that one, Misha, if you just do ... at the end without the final. So that will effectively say, I want to find from the person table from, that's result 1. There you go. So now we're finding all the US users up until the end. Now, if you start with UK there, we're going to be finding all the UK users and the US users right up to the end of the table. And vice versa, you can do this between different values. So it's really, really powerful. Now, really important to note, this doesn't use any indexes under the hood. This is really optimal. It's just selecting what you want to select. And then on top of that, you can filter even further down. So you could then say where user age is greater than 18, or where created date is at 3 o'clock in the afternoon, or something like that. So obviously we don't have ages on that user record in our data, but you can do that easily. So complex IDs are really powerful, not only for being able to insert data, but also specifically when you're selecting that data. And really not as powerful, but interesting use case as well. You can also use object keys for the ID, can't you? So here you go. Misha's creating now a person with an object where we've actually got named values. Now, in the case of Surreal, in the case of Surreal, all of our object keys are sorted. So these person records will always be sorted by the object keys. So if we create age 18 and test 1, 2, 3. Do test first.
In there.
Yeah, before the age.
There we go.
Yeah, and now do test before the age.
Right. Test.
Perfect. There you go. So importantly, we actually arranges the keys so that age comes before test, and then it will order those among the other records as well. So you can then filter on those keys like you do with the arrays, but you have to bear in mind that the object keys are always sorted alphabetically. So you can do some powerful things there as well, and they're obviously named. So what have we not looked at? Anything we've missed out, Misha?
Well, on the topic of scaling your data, it's an interesting discussion that has come up many times. I'm not sure if we want to discuss it today, but possibly record IDs versus graph relations.
Yeah. Okay. I mean,
because it's very specific to a certain situation. So it's for the same thing in a different situation, in a different context, you might want to use like either a record ID or graph relation, just because the one might be more performant in such a situation.
Yeah, absolutely. Again, it always depends on the type of data that you have and the type of querying that you want to be doing later down the line, right? Now, you don't have to think about all of this up front, but it does help if you have an understanding of how you might be querying something down the line. Graph relations are really powerful, but if you can do as much within a record AD as possible, then that really gives you even better performance. And then you can extend that with graph and with other functionality. And that brings us on to another question of that type, which is, do you denormalize data into multiple tables? Do you have that data stored embedded within records? That's always a big question we have. So we'll jump onto that before we finish this stream, and we're going to look at creating some tags. Let's create some tags on a post. So here we go. We've got a post table, and that post table has a tags column, and the tags column has string values. So we would then be able to select all from the post table where tags contains SerilDB. So effectively, it's going to be going through every record in the table or on an index, and you can index the values in the array as well, so it's not an issue. But this is basically going to say, look, this is going to find all posts where SerilDB is contained in the tags field. Now, there are other ways of modeling this. So the second way is to model it with record IDs. So we're going to create a tag SerilDB. We're going to create a tag database. And then instead of an actual string value inside that tag, or inside that post, sorry, we're going to put the record IDs itself. So this is very similar, but what it does mean is we can actually then add other metadata to that tag value. But at the end of the day, we're still selecting data in the same way. So when we select all from the post table where the tags contain SerilDB, it's going to have to go through every record. And there you go. It's going to go through every record and filter out based on the tags. Now we can use indexes again, but it's still the same thing. Now, relations gives us even more powerful things. So we might say, look, we've got a post, but we want to, instead of creating pointers, as single directional pointers to a tags table, we're going to create a multi-directional link to this tags table. So now we've got tag SerilDB and tag database. And there you go. Tag SerilDB is assigned to post 1, 2, 3. And let's run that. Brilliant. So now we go select all from posts 1, 2, 3. Perfect. And then we're going to select the, I think it's in, isn't it? Yeah, the in assigned to. Is it assigned to?
Assigned to. We got them.
And there you go. Now what we've done here is we've pulled out the tags for a certain post, which is fine because we're selecting from a single post. But interestingly, if we want to find all posts, and let's say there are millions of posts, but only a few have the SerilDB tag, then we can actually go from the SerilDB tag and straight out to that post. So now we're selecting all posts. If we just had a select all beforehand, only because it makes it a bit clearer to users. There you go. So we're selecting all the posts from the SerilDB tag. Now that's going to be going to a single record, the SerilDB tag, and it's going to be following out the distinct links to those posts. So now instead of searching through the post table and filtering down, it's actually just following 4 records or 5 records or however many posts there are that have that tag out. So it's very efficient. So 3 completely different ways of modeling your data, depending on how you want to query it and depending on how large your table is, how much data you have in there, and how you want to insert that data as well. Always something to bear in mind, record relations, so graph edges, have slightly more cost to them when you're writing, but they enable you to do some really efficient queries if you know upfront how you want to be doing those queries. So really, really great way of handling your data. And SterilDB is very flexible. You can do it in many different ways. That kind of brings us to the end of this stream. I can't believe it's gone so quickly, 50 minutes already. But Misha, anything we've missed in your opinion?
I don't think so, but if we did, then definitely do let us know on Discord or any other platform that we're on, like GitHub, Stack Overflow, and we'll try to help you out.
Amazing, yeah. So we put it in the chat there on YouTube, but if you head over to our GitHub, if you've got any ideas, issues, bugs, feature requests, then jump into the SterilDB repository and add those to the GitHub issues list. If you want to chat to the community, ask questions, we're on there a lot. So if you jump into Discord, then we'll answer as many questions as we can in there. Otherwise, take a look at our documentation. It's always improving. We're always adding more to it. There's a lot that SterilDB can do, and lots of ways that people are using it that we're constantly trying to listen to and put down our documentation. So absolutely, if you've got thoughts or improvements that you would like to see on our documentation as well, feel free to add a pull request on the www.serildb.com repository in GitHub, and we appreciate every contribution and every addition made to the software, the website, and the SDKs as well. So thank you to everyone involved in everything from that perspective. Our next stream is going to be in 2 weeks' time, and we'll be joined by Maxwell, and we're going to be looking at how Rust has given SterilDB the edge in the database world, and why it's the language that anyone should choose, especially when they're building low-level applications like SterilDB. So
we love Rust over here.
Yeah, we love Rust. We're doing as much as we can with Rust as possible. So yeah, Misha, thank you. It's been great. Thank you to those who joined us, and thanks for the questions. Some really good questions there. I hope I answered them all. If not, jump in the Discord and ask away, and we'll try and answer them on there as well. But yeah, thank you to everyone who watched, and see you again soon.